Hello everyone. My name is Lurduma Reddy, Thirumala Reddy, and I'm a senior SAP consultant specializing in SAP basis and HANA administration with over 17 years of experience. I'm excited to welcome you all to this session. Today I will be talking about how to achieve zero downtime SAP HANA database using high availability with pacemaker cluster setup. In today's digital economy, where system outages can cost enterprises millions of dollars per hour, implementing robust high availability and disaster recovery solutions for SAP HANA in database has become mission critical. This presentation delivers an in-depth exploration of architecting zero downtime SAP HANA environments using pacemaker cluster. With a specific focus on performance optimized scale up and scale out systems replication configurations that achieve sub-minute recovery time objectives. In this side, we'll say about three pillars of SAP HANA high availability. The first one is fault tolerance, guaranteeing continuous operations through system replication and seamless failover, minimizing downtime and preventing data integrity. Second one is disaster recovery, protecting against catastrophic events with the geographically dispersed data centers and rapid recovery strategies for business continuity. The third one is tenant replication, managing multiple SAP HANA tenants, also called instances, with independent failover capabilities, enabling targeted recovery and resource optimization. Here we can see how to achieve time up to 99% with advanced features. Like the first one is system replication, ensuring high availability by maintaining a synchronized secondary instance ready to take over in case of a primary instance failure. This technique guarantees minimal downtime and maintains data consistency. Second one is proactive configurations, maximizing system utilization by allowing read-only access to the secondary instance. This approach provides a performance boost and improves the resource allocation while maintaining high availability. Third one is time travel capabilities, recovering from data corruption or accidental changes by leveraging SAP HANA's time travel functionality. This powerful feature enables a rollback to previous point in time, protecting time integrity and ensuring resilience. Here we see some real-world success stories and testing frameworks. Prevented data loss. Discover how rigorous testing of HA cluster identified and mitigated potential data loss incidents during planned maintenance, ensuring business continuity and protecting critical information. Next one is comprehensive testing framework. Learn about the comprehensive testing framework covering various scenarios including graceful failover, primary secondary node crashes, and maintenance windows, ensuring the robustness and reliability of your HA solution. Here we see how to achieve maximum performance using strategic scale up and scale out system replication architectures. First one is intelligent resource allocation. Leverage advanced SAP HANA configurations that dynamically allocate up to 90% of node resources like CPU or memory, optimizing computational efficiency and eliminating potential performance bottlenecks. The second one is seamless failover strategies. Implement preloaded secondary instances with sophisticated synchronization mechanisms, achieving sub-minute failover times and guaranteeing near zero operational interruption during critical system events. Here we will see how can we leverage proactive read-enabled configurations, dynamic read distribution, intelligently distribute read-only transactions across synchronized HANA instances, minimizing primary instance load and improving overall system responsiveness. Next one is linear performance scaling, unlock up to 100% additional computation capacity by enabling parallel read workloads across primary and secondary nodes without compromising data consistency. Here we'll see how to implement foolproof takeover decision frameworks. The first one is conduct comprehensive node health assessments using multidimensional metrics such as analyze system performance, memory utilization, network connectivity, and real-time response times to create a holistic view of cluster node status. The second one is implement SAP Node 2063657 best practices. Integrate SAP's official guidance for configuring precise failover thresholds, defining weighted decision metrics, and establishing automatic recovery protocols. The last one is design adaptive failover strategies with intelligent resource management. Create dynamic decision frameworks that prioritize workload continuity, minimize potential data loss, and optimize computational resource allocation during node transitions. Here we see how can we architect for scalability and future growth of high availability solution. The first one is predictive scaling. Anticipate future growth and design your HA solution with scalability in mind, ensuring seamless expansion and adoption as your business demands increase. The second one is modular design. Build a modular architecture allowing for incremental scaling and easy adoption of new components as your system expands, maintaining flexibility and adaptability. The third one is automated provisioning. Embrace automated provisioning tools to simplify infrastructure management and enable rapid scaling, ensuring agility and responsiveness in a constantly evolving environment. Here, these are one of the most important recommendations how to secure your high availability architecture. The first one is access control. Implement strict access control measurements to restrict unauthorized access to your HA infrastructure, protecting critical systems and sensitive data. Next one is data encryption. Ensure data confidentiality and integrity through encryption at rest and in transit, safeguarding sensitive information from potential breaches. The third one is regular security audits. Conduct regular security audits to identify vulnerabilities and implement necessary security updates, ensuring the ongoing protection of your HA architecture. Here we see how to monitor and maintain the HA solution for optimal performance. Real-time monitoring. Deploy advanced monitoring solutions like Prometheus and Grafana to continuously track critical performance metrics such as CPU utilization, memory consumption, network latency, and system response times. The next one is proactive maintenance. Develop a comprehensive risk-based maintenance strategy that includes automated patch management, regular system health assessments, performance tuning, and scheduled infrastructure reviews. Here we'll go through some key takeaways and next steps. By leveraging pacemaker cluster and implementing best practices for system replication, practical configurations, and robust failover mechanism, we can achieve is true zero downtime SAP HANA environment, maximizing system availability and resilience. Remember to prioritize testing, security, and ongoing monitoring to maintain optimal performance and ensure the long-term success of your high availability solution. Thank you everyone for joining this session. Have a great day.